Don't make this mistake. When you have used the K method, it was for the convenience to what? To be able to solve this, right? But don't forget, they were asking, the question said we must solve for x. So now when I'm at this stage, I must now let K go back to its original form. So now I'm saying that I've got 2 to the power x, which is equal to 0, or 2 to the power x. Wait a minute, I made a mistake here. I'm not supposed to, excuse me, I'm supposed to say 2 to the power x plus 3 is equal to 0, or 2 to the power x minus 2 is equal to 0, right? Now, I transpose this positive 3, I've got 2 to the power x, which is equal to negative 3, right? Or, on the other side, I've got 2 to the power x, which is equals to positive 2. So this one I can immediately say that this is invalid. Why? Because here my x were positive, so I can't continue because there's a negative here. However, here now I've got 2 to the power x, which is equals to 2. I divide by 2, I divide by 2, so I can conclude that therefore my x is equals to 1. This is the only answer. This one is not an answer, and for doing that I get my 3 marks. So far, how many marks have we collected? Because the algebra section had 30 marks all in all last year, June 2025, Gauteng Province, right? So far it's 4 plus 3, 7 plus 4, 11, 13. So 13 out of 30, 2 more marks for someone to get to 50%. All right, so we now go to question 1.1.5, whereby we are given something which looks complicated. However, in reality, it is not. We are given x squared minus 2x plus 3 plus x squared minus 2x, and then the numerator is 2, which is equals to 0. Now, we need to use the K method again. Why? Because observe the thing which I'm seeing. I've got x squared minus 2x here on the denominator. I've got x squared minus 2x as the first 2 terms. So I will come here and say, let x squared minus 2x equal to what? Equal to y. So when we say K method, it doesn't mean to say that you have to use the letter y only. You can use the letter y, or you can use the letter a. So which means that where there is x squared minus 2x, I no longer write these 2 terms, I now write letter y. So here, I'm now going to substitute that with y. So it now reads like this, my equation. Y plus 3 plus 2 over y is equal to 0. Just like that. Now, I don't want to continue working with what? With a denominator. So I'm going to multiply by y on all terms. So now it becomes y multiplied by y plus 3 multiplied by y plus 2 over y multiplied by y is equals to 0 multiplied by y. This y cancels out that y. And y times y gives us y squared plus 3 times y is equals to 3y. Here I've got plus 2, which is equals to 0. From there now, what do I need to do? I need to factorize. So which means that here on this side I've got y, and on the other side I've got y, which is equals to 0. Now I've got 2, and the factors of 2 are what? Positive 1 and positive 2, right? When I proceed now, I'm saying that I've got y plus 1 is equals to 0, or y plus 2 is equals to 0. But I must not forget I've got x squared minus 2x, which is being represented by y. So now I substitute and say that I've got x squared minus 2x plus 1 is equal to 0, or I've got what? X squared minus 2x plus 2, which is equals to 0. Now, this x and x, what do I have here? I've got x and x, which is equals to 0. I've got a positive 1 here, there's a negative, which means here there was a negative and a negative. And for me to get 1, I only have got 1 and 1, right? And then when I go to the other side, I can't factorize this, right? Because if I try to find these 2, remember, I will have what? I can't do it. I can't do it. So in other words here now, I've got x minus 1, which is equals to 0. Observe, this is the same as saying that I've got x minus 1 what? Squared, because these are identical, which is equal to 0. And when I want to get rid of the squared, I must use a what? I must use a square root. So I use square root there, I use a square root there. Now I'm left with x minus 1, which is equals to 0. Therefore, my x is equals to 1, right? So this is my solution, right? Okay. So here on the other side, I write that this is invalid. Okay. All right. So let's go to 1.1.6, whereby we're given a surd. All right. So when we are dealing with surds, you must remember to use your what? Your squared, right? So we are given x plus 5, square root of x plus 5 minus x, which is equals to negative 1. So first order of business, it is to transpose this negative so that it goes to the right-hand side. So now I say that I've got x plus 5, which is equals to x minus 1. This is a square root. Now, since I'm having this, like I said earlier on, I use a square to get rid of the square root. And what I've done on the left-hand side, I must do on the right-hand side. This cancels out that. So I'm left with x plus 5, which is equals to, now, this x minus 1 squared, it needs me to expand. So it becomes x minus 1 multiplied by x minus 1. So here I've got x plus 5, which is equals to x times x, that's x squared. Then positive times negative, that's a negative. 1 times x, it's x. Negative and positive, negative. 1 times x, that's x. Negative times negative, that's a positive. 1 times 1, that is 1. X plus 5 is equals to, now here we've got x squared, negative x, that's negative 2x plus 1. Now what am I going to do? Now I'm going to say 0 is equals to x squared minus 2x. This was a positive x, it becomes a negative x. Then here we've got positive 1, and this was a positive 5, it becomes a negative 5. As we continue, these two, this negative 2x and negative x, these are like terms. So negative 2x, negative x, it gives us what? Negative 3x. So we've got x squared minus 3x. 1 minus 5 is equals to negative 4. So now we say x squared minus 3x minus 4 is equals to 0. Now we factorize and we say that here we've got x, and there we've got another x, which is also equal to 0. We want the factors of negative 4, which gives us a negative 3. So which means that here I've got a positive 1 and a negative 4, because now this and that positive times negative, it will give us this negative, but 1 minus 4, it will give us negative 3, which is what is here. So as we continue now, we say that we've got x plus 1, which is equal to 0, or x minus 4, which is equals to 0. X is equal to negative 1, or x is equals to 4. Now, observe, I'm not rushing to say that therefore. Why? Because now I must first satisfy, try and satisfy this surd. Meaning to say that where there is negative 1, I'm going to substitute it. So in other words, now I've got square root of negative 1 plus 5. Here there was minus x, which means there is minus, open bracket, negative is equals to negative 1. Negative 1 plus 5, that's square root of 4. A negative times negative, that's a positive 1, right? Square root of 4 is equals to what? It is equals to 2. And here, wait a minute, why am I writing positive 2? I've got 1 here. 2 plus 1 is equals to 3, but here we're given negative 1. So, which means that this negative 1 is invalid. So it's not part of the solutions. It's not a solution. So I come here and I write invalid here. That is why I didn't write therefore, because the moment I write therefore, it implies that it is a solution. However, it has been proven that it's not a solution. So now I substitute with 4. So now I say 4 plus 5, this is the square root, minus 4 here. 4 plus 5 is equals to 9, so I've got square root of 9 minus 4. And square root of 9 is equals to 3, so I've got 3 minus 4, which gives me negative 1. And there I was given negative 1, which means that this is a solution. So I write my therefore, then the examiner knows that I'm saying this is the solution. And just like that, I have collected my marks here. Now I didn't write the mark allocation, but let's see. 6 plus 3, that's 9, 13, 16, 20, 24, 26, which means that this was allocated 4 marks. Remember I said that this section had 30 marks. They allocated 30 marks. So just like that, we are done. Now we go to question 1.2. Question 1.2, it deals with what? Simultaneous equations. We are simply saying that we have been provided with 2 different equations, but they've got a common thing, these 2 different equations, right? So the common thing which they have, here we've been presented x plus 2y. This is a what? This is a straight line, but it is a declining function. How do I know that? Because when I've got x plus 2y is equals to 5, and I say 2y is equals to, and I transpose this, it becomes negative x. And the moment I've got a negative, it means the gradient is negative. This is the type of line that I have, right? And then I've got 2y squared. So the point which I want to make is whether this parabola looks like this. We're being told that there is a point where the x is, where these 2 graphs are meeting, where they intersect. So their x and y coordinate at the first point of intersection, they are having identical. And they've got a second point of intersection where they share the x and y coordinates, hence simultaneous equation, right? So now, here I'm given x plus 2y, so I'm going to write that x plus 2y is my first equation. X plus 2y is equals to 5, so I say dot, 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 therefore, this is my first equation. And then I've got 2y squared minus xy minus 4x squared, which is equal to 8. I say this is my second equation. Now I'm going to use equation number 1 to create equation number 3. So in other words, now I'm saying x is equals to negative 2y plus 5, and I say this is my third equation. I'm using the method of substitution, and I can't substitute where there is x. I'm not going to use negative 2y plus 5. But I derived this third equation using first equation. So I can't substitute into the first equation because it will give me 0. So now I'm going to use equation 2. I will substitute into equation 2. Meaning to say that here I now write 2y squared minus, here there is x, I now write open bracket negative 2y plus 5 multiplied by y minus 4 open bracket. Here it says x squared, which means I now write negative 2y plus 5 multiplied by another negative 2y plus 5. Like that. And it is equal to 8. It is equal to 8, like that. So from there, what do I do? Now I have to multiply. So now I rewrite 2y squared. I rewrite this minus. Now I say this negative times positive, open bracket. Now I've got negative 2, then y times y, which gives me y squared. Then I now say y multiplied by 5, which gives me 5y. I close the bracket. And if I come here, I'm going to rewrite this negative 4. It must await its turn to multiply with this bracket. So I will start multiplying these 2 brackets. So I will say open bracket, negative times negative, that's a positive, and 2 times 2, that's 4. Y by y, that's y squared. Negative and positive, that's a negative. 2 by 5, that's 10. And we've got y, there's no y, that's negative 10y. Positive and negative, negative, and then same true, negative 10y. Then positive and positive, that's a positive, and 5 by 5, that is positive 25. Close bracket, which is equals to 8. Now, when I come this side, now we are going to multiply the negative into these 2 terms, the binomial. So we say here we've got 2y squared, negative and negative, that's a positive 2y squared, negative and positive, that's a negative 5y. Now here we have got what? We have got like terms, negative 10y, negative 10y. So I rewrite this negative 4. It still awaits its turn to multiply with this trinomial here. So we've got 4y squared, and here we found negative 20y plus 25, close bracket, which is equals to 8. Now here we've got 2y squared plus 2y squared, which gives us 4y squared. So we write 4y squared here minus 5y. Now we're going to say negative times this positive, it's a negative 4 by 4, that's 16y squared. Negative and negative, that's a positive 4 by 20, that is 80y. And negative and positive, that's a negative 25 times 4, that is 100, which is equals to 8. Let's look for like terms. Now observe, 4y squared here is a like term of negative 16. Right, so it means 4 minus 16, which gives us negative 12. So we now write negative 12y squared. I've got negative 5y, I've got positive 80y. It's 80 minus 5, which gives me 75. So I've got positive 75y here. I mark them so that I don't repeat them. And then here I've got negative 100, and here I've got 8. So I transpose, and I now write it as negative 108, which is equals to 0. Now, when I'm here, I've got 12, 75, and 108. I don't want to crack my head. Remember, what did they say? That I should solve for x. So what will I do? I'm just going to divide by negative 1 because I don't want to work with a negative coefficient of y squared. So I divide by negative, negative, and negative. Negative and negative, it's a positive, so now I've got positive 12y squared plus minus positive and negative divided by negative, it's a negative 75. Y negative and negative, that's a positive 108, which is equals to 0. Now I'm going to use the quadratic formula to solve this, to solve for y. So now I say y is equal to my b. Remember, this is a, this is b, and that is c. So my b is negative. So I say negative, open bracket, negative 75, close bracket, plus or minus square root of what? B squared, which is open bracket, negative 75, close bracket, squared, minus 4 multiplied by a, which is 12, close bracket, multiplied by c, which is positive 108. Like that. Then I say open, close the square root, and then 2 multiplied by a, my a is what? 12. Like that. Now I go and I consult my calculator for this particular section, right? So obviously negative and negative gives me a what? A positive. So here I will now say that positive 75 and plus, so I'm going to write, well, let me start with negative rather, minus square root of what? Open bracket, negative 75, close bracket, squared, minus 4, open bracket, a is 12, close bracket, my c, I open the bracket, which is 108, close bracket, all over. 2 by 12 is 24, so this is all over, not 2,444, all over 24, which is equals to 4. So we say, therefore, y is equals to 4, or y is equals to. Now, because I started by a positive, let me go to a negative. Let me go to a negative. Right, I delete, so I place a negative, which is 9 over 4. Y is equals to 9 over 4. Now that I found these two, what do? I'm going to now use equation 1. Where there is y, at first I will use 9 over 4. The second time I will use 4 to find my x. Remember, they said I must solve for x and y under simultaneous equation. Don't hurry. Just because it was tedious, it was a lot of work, and you found y and y there, don't celebrate and say that you have found the answers. You still have to find your x coordinates. So I'm now going to use this section of the board. Right now, I say here, I've got x plus 2, right? Now I call it 2 over 1, multiplied by 9 over 4, right? Which is equals to 5. Now I say 2 into 2, that's 1. 2 into 4, that's 2. Now I've got x plus 9 over 2, which is equals to 5. I don't want to continue working with the denominator, so I multiply by 2 here, I multiply by 2 there, and I multiply by 2 there. These 2 and that 2, they cancel out. 2 by x, that is 2x plus 9, which is equals to 5 by 2, that is 10. I now transpose this 9, it now reads as follows. 2x is equals to 10 minus 9. 2x is equals to 1 divided by 2 divided by 2. So I say, therefore, my x is equal to a half. So when my y is 9 over 4, here, the x is 1 over 2. Now I want to know when my y is 4, what is the x? So I now say x plus 2 open bracket 4 is equal to 5. This is 2 by 4, which is 8. So I say x is equals to 5 minus 8. Therefore, x is equals to negative 3. So when the y is 4, the x is negative 3. And just like that, you get your 6 marks for all of this work. So the first part was the one which was tedious. Finding the other coordinate as easy as eating pap. Now we go to the last question, and the last question was simple for me. For other people, they tend to forget the nature of roots. The nature of roots, you've got three different types of the nature of roots. So just go and revisit your grade 11 work so that you can remind yourself of what you did in term 1. So let's hear the question. They say, for which values of k will the roots of 6x squared plus 6 equals to 4kx be real and equal, right? So for which roots of k will it be real and equal? So first thing which I do, I now say 6x squared. I transpose this, it becomes negative 4kx plus 6 is equal to 0, right? So why did I do that? Because observe here, this 6 is A, this negative 4k here, this is B, and here, this 6 is C. So here we are going to be dealing with the discriminant. So we say discriminant is equals to b squared minus 4ac, right? So we say discriminant is equals to the b squared. Now we say open bracket negative 4k close bracket squared minus 4 multiplied by a. Our a is 6 and our c is also 6 there. Now the discriminant is equals to, inside the bracket negative 4 squared gives us 16, and k squared, that's k squared. And then here we've got 6 by 6, which is 36, and we've got negative times positive, which is a negative. Now we've got 36 times 4, but 36 plus 36 gives me 72. So basically it's 72 plus 72, which is 144 there. So the discriminant is saying is equals to 16k squared minus 144. But because they say that they are real, which means that they are part of real numbers and they are equal, it means that the discriminant is equals to 0. So now I write 16k squared minus 144 is equal to 0. So I transpose the negative 144, it becomes 16k squared is equals to 144. I divide by 16, I divide by 16. 16 to 16 it's 1. So here I've got k squared, which is equals to 144 over 16. I go to my calculator, I have to input 144 over 16, 144 divided by 16 is equal to 9. So here I've got 9, right? But now, what am I looking for? For k, I'm not looking for k squared. So now I come and I say square root of, but the square root gets rid of the squared. Now here I say plus or minus, right? So therefore, my k is equals to plus or minus 3. That's my answer, and I get my 3 marks, just like that. And We've come to the end of the paper, the algebra section, which had 36 marks, which was written in Gauteng in 2025. The next part will be dealing with what? Numbers, sequence, and series, right? So if you found this video to be helpful, please do consider subscribing, liking, and commenting. Make suggestions of the videos that you would like to watch where you are struggling as you prepare for your prelims, right? From me to you, till we meet next time. Cheers.